Yeah. Hi, everyone. I'm Chris. I actually lived in Melbourne for 6 years and helped organize the Elixir Melbourne meetup for a little bit towards the end there. So Australia is near and dear to my heart. My wife is Australian, and I'm excited to be here and talk to you guys a little bit about machine learning. Um, I saw in the chat there's some people from basically all over, including I saw like Estonia, Perth, like just I'm based in the Netherlands now. And I think that, building these kind of global links is really important. And I think it's a really exciting thing to see that kind of being forged forward in Australia. Um, so today or tonight for you guys, I'll be talking about machine learning in Elixir. I'm going to give you a practical guide. I noticed somebody in the chat said that they had seen the talk I gave at ElixirConf earlier this year about this. And I'm going to be using a lot of the same slides, and it's going to have a lot of the same kind of content, but the focus is going to be quite different. I'm going to talk through these slides with a different perspective, which is really about the practicalities, right? It's really going to be about how do we go from the theoretical side of things to getting the rubber to the road and actually producing features using machine learning with Elixir, because I think that combination is one of the most powerful out there. I certainly consider it a secret weapon for my company. And I think that there's a lot that we can do as Elixir developers that other people using other languages and doing other things actually can't do. And I also think that it's an under kind of represented area of Elixir development where people are just kind of not as aware of what we're able to do there. It's really developed over the past couple of years, and it's 100% production ready. And I think that there's really great opportunity to be using it. So let's go ahead and get started. I'm going to keep an eye on the time. I can actually see my clock. That's great. So the first thing I'm going to do is just give you a quick introduction to my company and who I am, really, really briefly. And the reason why I'm doing that is because the whenever you are making a product, whenever you are building something using machine learning in Elixir, anywhere, it's just such a big field that there's always going to be a focus or a limited area that you're actually thinking about and using. So our main focus is on natural language processing, working with natural language and text with computers. And we do that from the perspective of working with patents. I'm the founder and CTO of Amplified. As it says on the screen, we do AI assisted innovation intelligence. So the idea is effectively that you're able to be superpowered by our various AI workflows to allow you to do things like patent search, which sometimes is called prior art search, to be able to classify things, apply tags, to see landscapes of the kind of like the innovation landscape, all sorts of things like that. So I'm going to show you a quick video that gives you just a quick overview of what we're doing so that you can kind of see where I'm coming from and some of the emphases that I'll be putting on what I'm doing. I'll try to flag as I go where I'm only covering a small portion of what's available. So let's click that and let's get started. So when you first come into Amplified, you'll see like a library of projects, and we organize everything into a project. And this is what an empty project looks like. So I'm going to click to get this video started. And what you'll see is that I'm going to enter a natural language description of an invention. That allows me to go and search for things that are similar. I'm going to turn on a keyword Boolean filter. So I'm going to limit my search by that Boolean filter. And then I'm going to sort it by the similarity to the invention description. So you can see some of the results there. And then I'm going to do a bulk select all 218 patents. So those are that's the result set that we got from the search that we did. I'm going to apply a tag and a generated classification model that I've already trained. It's going to go through and apply that classification model and predict the existence of, or predict whether we should apply a tag to the result set that we got. You can see some of these predictions are green and some of them are red. Green means that it's above a calculated cutoff, and red means that it's below. And then we can actually go through and sort by the score that we got from the classifier. So We can then go and we can visualize the results. Just take a moment for it to load. But what we're going to see here is kind of a map of those patents in a two-dimensional space, where we can see we've got labeled clusters. We can zoom in on those clusters. We can see that this area is about qubit coupling methods. We can see that there are patents that are very similar there. You zoom back out and look at some of the different groups and clusters that you've got there. You can group by publications or simple families, and you can change the color. So you can take that tag score that we had before from the qubit generation, and you can actually see where the patents are that have the highest scores and the patents that have the lowest scores. It allows you to kind of explore that in a really interactive way and understand the space that you're looking at. You can see some of the details from the patents. This space over here is quantum computing. Yeah. So sorry, it's quite warm here. Summer just hit, and I've got the windows open, and I've just got some flies and mozzies coming in. So I'll try to avoid all of this. So kind of what gives you the power to do this sort of thing? This is all built with Elixir. There's no other language here. We're using LiveView. And so what can we use? What are the tools that we need to build this sort of stuff? We'll get into that tonight, and we're going to talk through all of it. So I'll just give you a quick little bit of background. For me, I've been doing this for a while. I've been preaching this message for a little while, where 2 years ago or 3 years ago now, I went up at ElixirConf in the US, and I said that I'm betting on an all Elixir future from ETL to deep learning. And that was 2 years ago. It was in 2022. And really did kind of bet the company on this. We believed that it was the way forward, and we've been investing in it and building on it. So last year, then I was able to kind of recap a year of putting it in production. And I just really quickly want to share some of the highlights there, which is that we were able to eradicate Python from our pipelines completely. We had Python in ETL, so extract, transform, load kind of data processing pipelines, as well as our machine learning workflows. And those two things are pretty integrated if you're doing a lot of machine learning. We were able to slash our monthly AWS spend in half. Huge win. But part of that is just that Elixir has particular kind of happy paths and makes certain things very easy, like streaming, like multi-stage work, things like GenStage and Broadway make it very easy to do ETL and put pieces together that are much more efficient. So when we were doing it in Python, we were kind of working with some workflow orchestration tools like I can't remember the Prefect. Sorry, my brain does this sometimes. So we were working with Prefect, and it was just really, really expensive and kludgy. And we ended up having these giant tables that we had to join together and all this stuff. And now we do streaming, and it's much more efficient. We've got faster bulk loading, which is important as we're experimenting with models. We've got better and more observability. Part of that is just down to integrating into an existing stack and kind of like circling the wagons around. But part of it is just that there's a lot of really good work that's been done in Elixir over the past 4 or 5 years since the kind of advent of the telemetry project, that gives kind of a unified API for observability. And all of this can be applied to machine learning. When you are working with machine learning in Elixir, one of the messages that's going to come through over and over again tonight is just that you're just working in Elixir. It feels like Elixir. It acts like Elixir. It is. You don't have to learn some separate API. You don't have to jump through hoops to do the work that you want to do. It all just kind of works. That's the last point. So let's just really briefly cover this. So what I'm going to cover tonight is I'm going to talk about the ecosystem. I did that mostly in depth at the ElixirConf talk. I'm going to kind of breeze through that a little bit more tonight. It's important, and it's kind of the bedrock of how you understand what you're doing. But I really want to focus on the practicalities tonight. So that's what we're going to do. We're going to talk about how you ship it. What are some of the things that I've learned that I can share with you about how to actually do that, how to bring it to production. And then I'll show you a couple of examples, and we'll talk through what we had to do to make those happen. So let's talk about the ecosystem. You fit it all in one slide. It's pretty great that you can do that. Joseph Allen, the creator of the language, was also one of the main creators of NX, and he has been kind of focusing a lot of his time on the machine learning side of things. He's a superhuman human being. It's kind of ridiculous how much he's able to cover. So that's not his only focus, but he's spent a lot of time there, and it shows. So there are these kind of happy path approaches. You don't have to worry about the fragmentation of the ecosystem so much. We know that there's a core set of libraries that all kind of revolve around NX. And if you have experience doing machine learning in Python or something else, you'll know that there's kind of a fragmentation. It's, do you use JAX? Do you use TensorFlow? Do you use do you use NumPy for various things? Do you use PyTorch? All of these different things. And then there are ecosystems around each of those choices as well. So there's like PyTorch Lightning, there's Keras, all these different kind of libraries that you have to pick and choose. And you end up with a lot of fragmentation, a lot of challenges. Everything is kind of in one place in Elixir, and that gives us a lot of power. We don't have to make those decisions, but it also means that we're a smaller community, and the focus of our efforts as a smaller community can go into a smaller number of libraries that we can make really shine, give them a lot of love. And as you're going to see when we talk about NX, it's not just that we're circling the wagons around one library. It's that library is built for flexibility, and it's built to be extended. So there's a kind of aspect of the abilities of Elixir for things like metaprogramming and things like that give us a lot of power in creating something where other languages are not able to, or haven't taken the same kind of architectural decisions. So we're going to talk about the NX stack, right? When I say the NX ecosystem, we're talking about, a shift to machine learning that's happened in Elixir over the past couple of years. And that's kind of a broad historical trend, I guess you can call that, over the past couple of years. And so that includes things like Livebook and Explorer and Vega Lite, where we're bringing in the libraries that are necessary to do the kind of work that you do with machine learning. But specifically when we're talking about the NX stack, we're talking about the libraries that are built on top of NX. And how they play nicely together and things like that. So let's start by talking about NX. This is the kind of core of all of the machine learning work that we'll do in Elixir. It may not be something that you're actually interacting with directly. You certainly will be configuring it, but you may not be using NX functions directly because there are higher level libraries that build on them. But it's really important to have a general understanding of how NX works so that you can then be more informed when you're doing higher level stuff, and you can understand what's going on, if things break, if things go wrong, or just how to be more efficient, how to build things in a better way. Maybe you want to extend a library, something like that. So NX is a multidimensional tensor library for Elixir, and it has multi-stage compilation to this GPU and CPU. So this sentence, it carries a lot of meaning. And we're going to see, I'm going to go through and kind of do a very similar thing here with each of these libraries. We're going to understand what they mean. So let's start with a tensor. What is a tensor? It's not a tensor. So in maths, a tensor is something different than what we call a tensor in machine learning jargon, right? So it's a data structure, and that's what's really important to understand. It looks like this. It's a multidimensional array. And we all have experience with multidimensional arrays, even if we don't realize we've done it. We think about like two-dimensional data structures, tabular data structures, right? You have tables in SQL, you have tables in Excel. We all kind of understand how these work. The thing about arrays and about multidimensional arrays, and the thing about tensors is that they have a few restrictions, right? So they are they're basically always, or they always have to be of the same type, and that's the kind of restriction that we have there. And they'll be mathematical, so they'll be numerical. So you can have different precision levels of like floats or integers or things like that, but they're always going to be numeric in some way. Sometimes they're bytes, which again that's a way of kind of shoving certain kinds of information there. But it's always going to be numerical in some sense. And this is what it looks like in Elixir. right? So this is what an NX tensor looks like. You get you can see the S64 means that it's a signed 64-bit integer. And you can see the dimensions of the different, sorry, you can see the names of the different dimensions. And multidimensional arrays can be arbitrarily, have an arbitrary number of dimensions. But you can just kind of think of them, if you have some familiarity with maths, you can think of, matrices. And then as we go wider with that, you can have, 3-dimensionals and 4-dimensional and 5-dimensional. Okay. Oh, here we go. So let's get back here. Sorry. My clicking is not giving me what I like. There we go. And so then I want to focus a little bit about on this concept of multi-stage compilation, because you may be wondering, like, you've heard the Beam doesn't handle maths very well. You know that like Erlang and Elixir, these aren't like mathematically focused languages. So this is what I think the coolest part of NX is, and it's one of the things to really try to wrap your head around and understand, and it's really fundamental to understanding everything else, is that we're using native implemented functions. So we're using NIFs, which are ways of utilizing other languages in, well, Erlang, and then in Elixir by extension. And what you are able to do is use different, what we call backends, which are a behavior. So if you're familiar with polymorphism, in Elixir, we have behaviors, we have protocols, and this, NX is really around a behavior. It's a contract, right? And we have many backends that can fulfill that contract. So there's a binary backend built in, which is just pure Elixir, and it's very slow. So you can use it. You can actually do all of the NX operations, or most of the NX operations, with with this binary backend, but it's going to be slow. So what we use are libraries like EXLA or TorchX, and those libraries provide basically a call out to another language, usually in this case C++, to fulfill the contract functions that we have in X. There's one aspect of this, which is that there's a difference between backends and compilers. And when we talk about multi-stage compilation, the multi-stage part is kind of important there as well. And what that means is that we can take the same Elixir code that we've written for, where we've done these NX operations, and we can actually have it compiled to run on different hardware. So the exact same code can be run on TPUs or GPUs, and it doesn't care. It's agnostic. And I think that this is really powerful. So Sean Moriarty, one of the original authors of NX and the author of Axon, which we'll get to in just a moment, he's written a book on machine learning in Elixir. I really recommend checking it out. But what he says here is that the relationship between backends and compilers is kind of like the relationship between interpreted programming languages and compiled programming languages. So when we use a backend, we can call functions that do work on things like on the GPUs or TPUs or what have you. But when we're using compilation, we're basically taking the Elixir code, and we are producing we're producing a tree, right? An abstract syntax tree, and we're then doing a compilation to EXLA, and then EXLA is taking that and then using things like LLVM, I think that's correct, or HLO, and compiling that to the code that needs to be run on the CPU, or on the GPU or the TPU or the CPU for that matter. So some things to understand with that are that in order to optimize that, we need to use a thing called defn, which Jose wrote. It's basically a macro like def or defp. It's defn, which is specifically numerical computation, right? And it's a superset of Elixir, and it allows for kind of building that computational graph that I mentioned before. So if you inspect it, it looks like this. So you can see kind of what's happening with that graph. You can see that we've got these different parameters. We can understand what those parameters are doing and kind of the different steps that are happening in the computational graph that we need to produce. So what are you going to use NX for? It's the foundation of the other libraries, as I mentioned. You often won't be writing a lot of NX directly, as I said, but you may, if this is your area of expertise, if you have a mathematical background, if you want to contribute to other libraries, great. Just generally understanding what's going on underneath really helps us with everything that we want to do. And doing some basic tensor operations and understanding what can be put into def-n allows you to write more efficient code when you need to kind of break out from the higher level libraries. So similar to like NumPy, JAX, PyTorch, TensorFlow, Theno, if you are familiar with Python, those are some of the libraries that you'll see. Axon is built on top of NX, and it's a library for, NX-powered neural networks for Elixir. We're going to go through these really, really briefly. This is going to be a kind of a whistle-stop tour here. So it gives you a set of libraries or a set of modules that kind of cover the things that you need to do if you want to write machine learning or write neural networks. So you don't have to write all your NX operations from scratch. You've got these kind of high-level things, as well as a really nice interface for training and things like that. I really like the way that models are basically just a pipeline in Axon. I think that that's a really clear way of understanding the way that machine learning models work. And if you kind of understand this and kind of see that this is how Axon builds up models and understand the concept of an Axon model, then that's going to help you understand some of the higher level libraries that we'll get to in just a bit. You can go and actually look at the way that the model is built and what the neural network will actually look like, and this shows you the different layers. And then we've got this like Axon loop, which makes training simple as well. And this is something that you'll need to understand if you're doing any kind of fine tuning, if you're training your own models, things like that. So Axon has a really nice interface for training machine learning models, and it allows you to kind of hook into it to call other processes, do really cool stuff. And you can kind of see, what this looks like. So let's say you hit train, and you'll kind of see we've got like epoch and the batch number and the loss all come through. So you use it for writing your own neural networks, training those neural networks, and it's really similar to like PyTorch, PyTorch Ignite, Lightning, TensorFlow, Keras, that sort of stuff. It's a higher level library for this sort of thing. So then the kind of highest level here when we're talking about the NX ecosystem is Bumblebee. And Bumblebee provides pre-trained neural network models on top of Axon. That's really cool. It means that we can reach another level of abstraction, and we can then apply that when we're doing work. So we don't have to implement existing things. And one of the really powerful things about what Bumblebee does is that it includes integration with Hugging Face models. If you're not familiar with Hugging Face, it's kind of the 10,000-pound elephant, gorilla, whatever it is in the room. And they provide a space where you can put up pre-trained models. So all of the kind of large models that have been put out from everyone, basically all of the big companies, anything where there are open weights, they're typically on Hugging Face models, and you can go and pull those weights and utilize them elsewhere. Being able to tap into that kind of model zoo is one of the most powerful things that you have in machine learning these days, because most of the models that you're going to use are not going to be models that you train from scratch. They're going to be models that somebody else has already trained. It would be crazy to go and train these, multi-million model or even billion parameter models from scratch every time you wanted to use them. And nobody has the money or the time or anything except from Google or Meta or whoever. But then you can also put things like fine tuning and stuff like that on there. So it looks like this. You can kind of see, you can go and do a search. You can see like there's Mixtral on there, like that's an 8 billion parameter model, absolutely massive, hundreds of GPUs over an extended period of time to train something like that over, something like a Common Crawl, Wikipedia, those kind of data sets that give you everything that exists. And we can pull those into Elixir. That's what's really amazing here is that, so Python has kind of had a stranglehold or a monopoly on this because most of the Hugging Face libraries that allow you to provide like a client to interact with these models, pull these models, and utilize these models are, Hugging Face, they build libraries in Python. Some of it's in Rust, but mostly in Python. And so the ability to represent those models as basically, as Axon models gives you just a huge amount of power and the ability to do things in a really arbitrary way. So this slide illustrates that. So instead of writing a whole bunch of code, going and understanding what tokenizers are, going and training a model in Axon, all of those different things, you can just do this. This is as simple as it comes. It's, 5 lines. And part of that is because Kino takes a couple of extra lines because this code was taken from a Livebook. Not every model is supported. There's a limitation on that in that you need to define the model in Axon first, but that's what the kind of library maintainers have been doing. And you can just go and pull these models just like this off the shelf. And if you've got the right kind of GPU, if you set up your kind of configuration correctly, they run just as fast as anything in Python. So it's incredibly convenient. So what do you want to use it for? I mean, it should be your first stop for deep learning in Elixir. Out of the box, you get LLM, stable diffusion, speech to text, image classification, text classification, question answering, text generation, like the list just goes on, right? And it's very similar to Hugging Face Transformers, which is a Python library that allows you to access those models from Python. Scholar is it's also a high level library. It's a way of doing kind of traditional machine learning in Elixir, and this is something that you will find comes up time and time again. The big models are, they're flashy. You've got the stuff that you're doing in terms of like text classification that's really cool, or generating text. I mean, generative AI is all the rage. You can do all sorts of awesome things with that. But sometimes you just need to be able to work with the outputs of those models, right? So sometimes, like in Amplified, we're talking a lot about embeddings. And, most of the things that you saw earlier in our example in the video I showed you are driven because we have good embeddings that are numerical representations of the text and patterns. And often you don't need deep learning once you have those embeddings or once you are doing something else. You can often just pull like much simpler models off the shelf, and they're going to do a lot for you. So traditional machine learning tools built on NX, you use it for things like regression, clustering, classification, dimensionality reduction, nearest neighbors. If you're not familiar with some of these terms, we're going to see them in action a little bit later in the talk, so you don't need to worry too much. But this is your big toolbox. This is where you've got like the scikit-learn style stuff if you're familiar with Python. We've also got Explorer, which is another tool that you will want to use when you're working with numerical data in Elixir. So Explorer is a data frame library. If you're not familiar with data frames, that's okay. Tabular data, as I mentioned before. So we get series, which are like one-dimensional, and data frames, which are two-dimensional data. It gives you really fast, elegant data exploration API, right? So it's built on top of Polars, which is a Rust library that has other clients as well. Like there's a PyPolars and things like that. And it actually also has pluggable backends. That's a separate point. But the idea is to take some of the best influences that we have from like the R data frame community. R has all sorts of warts, but they're really good at building APIs for interacting with data. And so we've kind of tried to learn from that and make it Elixir-ish and create this kind of data exploration library that allows the best benefits of like the speed of Polars and the kind of elegance of like dplyr and the whole tidyverse community in R. This is what a table will look like if you have Kino Explorer open and you're working in Livebook. And just to emphasize, like 80% of the time that of the time spent from data practitioners, it's really spent on like finding, cleaning, preparing data. We're all excited about the training part, the inference part, all of that stuff, but we've got to have good data. It's garbage in, garbage out, and Explorer allows you to do that without allocating too much brain space to trying to figure out how to like move things around, and it allows you to do it faster and more efficiently. both in terms of the computation time and in terms of your mental speed, right? It constrains your options, which is the kind of thing you have to think about it in terms of like simple verbs that allow you to do these kind of data manipulation tasks. So kind of looks like this. Very similar. What you'll note, what you might see is that it's very similar to NX tensors, and it actually implements a protocol defined by NX to allow you to do work directly on data frames. We actually have zero copy transfer. So you're able to allocate, or you're able to run NX stuff on data frame columns without actually copying, because we do some magic with like Apache Arrow and things like that under the hood. We're able to do that without serializing and deserializing the data, and it gives you a little bit of speed. So there's a bit of fun there. Use it for data manipulation. You can think about it as like database operations in memory, and a lot of the verbs are very similar to SQL. Data input output, data insights, that sort of stuff. It's similar to pandas, polars, R data frames, dplyr, and tidyr. So, and then the last kind of tool that you want to be thinking about is Livebook. Livebook is a web application for writing interactive and collaborative code notebooks. I'm going to skip past this part and just say, if you're not using Livebook, go use it. Go to Livebook, the website. It will change your experience of using Elixir. It's incredibly powerful. You can go, and many libraries are now providing runnable Livebooks in their documentation. You can go and pull those down and actually see the way that the library is meant to work. Writing code notebooks is really powerful, and Livebook utilizes a lot of the really cool stuff that we can do in Elixir, like connecting to remote nodes, clustering, and playing with processes, along with the fact that Elixir is it's an immutable functional language, to give you like really understandable, clearly understandable code notebooks that can do some really super powered stuff. So what do you use it for? I mean, literally everything. Just prototyping, reproducible reports, documentation, collaboration, interactive testing, all this stuff. You get to do it. It's very similar to Jupyter Notebooks. I prefer them. I think that there are a lot of benefits that they provide beyond what Jupyter Notebooks can do. There's some other things as well, like R Markdown and work mode, that are similar. So let's get to actually shipping it. And so I talked a little bit before about NX and the NX stack, right? So what do you need to do to ship it is you basically invert that pyramid. You want to start at the top. The higher level things are things like Bumblebee, things like Explorer is going to be something that you're using daily. Livebook is something that you're going to be using daily. And some of these libraries like Vega Lite, Instructor, XGBoost. I mean, there's an argument that XGBoost is all you need. It's a classification, right? And there's a library there for that. Toucan is actually a higher level on top of Vega Lite, so it allows you to write plotting and write plots and things like that really quickly. And so I'll just kind of jump into this. One of the places that you might want to start is actually not with running the machine learning part in Elixir at all. What's really cool that's starting to build up in the Elixir ecosystem with this is something like this, which is Instructor. Instructor is a way of writing, actually utilizing some of the most fundamental things that we're using as Elixir developers, like Ecto. So it's utilizing Ecto to coerce the output from LLMs. So you can use this with OpenAI. You can use this. I just saw that there's a PR that's about to be merged, or very likely to be merged with Claude, so Anthropic AI. It also works with like Llama's DPP if you want to use some local models and things like that. And it gives you the ability to say to your LLM, this is what I want you to respond with. It uses the descriptions that you've put into your fields to kind of coerce the output. And then you can use change sets. This is really powerful. You can use your change sets. If you write a change set, it allows, what it does is it takes it allows the generative model to send you some data. And if it doesn't match what you have in your change set, we use Ecto's natural language change set validation to send back the errors to the LLM and have it correct them until you get the output that you want. I think that this combination, this utilization of Ecto with an idea that came from the Python community is just incredibly powerful. And it's a really good kind of go-to. I understand that there's a Bumblebee attachment or a Bumblebee implementation or adapter, because it's again like this kind of adapter driven workflow where we utilize behaviors and we can implement an adapter protocol or an adapter behavior. And it allows you to kind of use different sources. But it's just a super powerful way to start with doing really powerful stuff with LLMs. And so you would then utilize it by doing something like this, where you call, sorry, I just went past that, where you call the chat completion, and you can give it the kind of prompt in the chat, and then it will go off and try to fulfill your prompt based on the return schema that you've given it. Really great. So start there, start at the top. And that doesn't even require utilizing some of the cool stuff that we've talked about. It just requires understanding Elixir. Then next, I would recommend, if you want to really get your hands dirty and start using things like Bumblebee or start using things to do with machine learning and Elixir, that you start with Bumblebee, right? I showed you before, it's 5 lines of code to get a model running. Incredibly powerful. There's a folder in the Bumblebee repository that shows you how to do this in live view. So it's got an image classification, speech to text, and text classification examples. I actually used the speech to text example just yesterday to build a feature in Amplified. It's really powerful, really easy. And Bumblebee can run Whisper. So you can do something like transcription very easily. What does it look like? So here's a text classification example. This is just a screenshot from GitHub showing you what the Bumblebee part looks like. There's other stuff to do with, building the live view, building, the actual view that you're doing. But this is all you need for actually running the Bumblebee side of things. You need to configure it. You need to load in the model. You need to load in the tokenizer, and then you give it to a function like text classification here with the serving. And you're able to utilize that. So what do I mean when I say serving, right? And this is where we get back to NX. And NX provides a module called NX serving. And Bumblebee utilizes that. And understanding the framework of how this works is really important for making practical decisions about how you're going to implement machine learning in Elixir. So it encapsulates client and server work to perform batch requests. When we're talking about client and server work, we're talking about processes, Elixir processes. These can be executed on the fly. The model can be executed here and there, but you are building basically a pipeline, and the model sits in a process. This is really important when you've got these big models, right, that require loading into memory, compilation. It's kind of slow on startup. You don't want to have to load them in every time you want to run something. And we can utilize the actor-based concurrency model of OTP to produce this server that is able to take requests from elsewhere. It's able to then batch them together, and it's completely transparent to the caller. So we get really efficient work being done by the GPU or TPU or what have you, because all this stuff works much more efficiently when you have a batch. And we're able to then send it back out. So you've got like client A, client B, client C. They all want to embed some text. They go call the serving, and the serving sends them back the thing that they asked for, and none of the clients know that the serving had batched them together and run it all at once. It uses a timeout or like a limit on the size of the batch. So either you send a number of messages that are smaller than the maximum batch size, and it will, after a timeout, respond. Or if you hit the maximum batch size, it will go ahead and process that and start taking in the other batches or the other messages afterwards. So you can see you just defined it in your application tree. You've got an NX serving, and it can be basically anything. But this is what Bumblebee is using. And when you're using Bumblebee, you are just basically producing a serving, which is a process that you're going to use in Elixir, right? So you just do batch run, and you get back a result. Okay, so just really briefly, You should also go through a quick deployment checklist when you're thinking about producing features or applications that utilize machine learning and Elixir. You want to use a compiler that's going to give you the best performance that you have, and then default to a corresponding backend. So EXLA is both a compiler and a backend, and you want to use both if you're for most purposes. EXLA is the go-to right now. There are other things that you can use, but that's the thing that you should be using. Just click this. You want to ensure that you're setting the right XLA target, because I've been hit with this. You want to make sure that you're focusing on the CPU, or sorry, you're telling it the right target for when it's doing this multi-stage compilation that we mentioned before. And you want to make sure that you're handling dirty IO threads for GPUs. So this is in the documentation. It's just something that's like a little gotcha, because we're working with NIFs, the native implemented functions. And because those will be long running, we want to ensure that we're letting it know that it's running in these dirty IO threads, and that we might need to make some changes to the underlying beam. Okay, and then use telemetry. Like we get messages coming through, we get to utilize telemetry the same way that we do with any other application. And you can see what's happening with like the batch size, the batch processing time over time. You can explore this as deeply as your observability heart gives you, makes you happy. And think about your clustered topology. So one last thing is that NX servings are distributed by default. If you allocate a serving to a GPU node or nodes, it's going to distribute for you. And it will, if the current machine that you're on, so let's say that you've got like a heterogeneous cluster where you've got some things that have GPUs and some don't, you may want to run the serving only on the GPUs. The nodes that are running on CPUs, they know that the current machine doesn't have an instance, but they can go and find one. So we get to use the kind of batching. I have run way over time, so I think I'll skip to the end and ask for some questions. Some of the examples that I wanted to talk about are available to view in the ElixirConf talk. So go do that if you want to see it kind of in action. But I'd love to answer some questions and kind of talk through what we discussed. Hopefully that gives you an idea of what you need to understand so that you can go and kind of practically bring this to your application. It's not scary. It's actually really, really easy, and we get a lot for free by working with Elixir. Thanks.
Oh, sorry, I didn't unmute for the applause. Let's do it again. Thanks, Chris. That was a great talk. You packed a lot in. Do we have any questions?
Yeah. We know everything about silicon support.
So Apple Silicon support, do we know what the latest on that is?
My understanding is that it's very, very soon. I know that there's some prototypes that are already out. There's been a move from EXLA originally was kind of part of the TensorFlow project. They then broke it out into its own library, and it utilizes other libraries for its multi-stage compilation. And my understanding is that there's some work being done to use HLO, which is another kind of emerging compiler, and we're going to be putting that into the EXLA project. And yeah, I think very soon, like weeks. I know that there's some prototypes out already.
Did you say weeks? Weeks away?
Maybe. My understanding, maybe months. But I don't tell Paolo that I said that, actually. Putting pressure on him. But I know that there are prototypes that are already out. Like it's close.
Now in the public domain. You've made promises. So
no, I make no promises. It's not me. I'm not doing it.
Luckily, you didn't say how many, so we're good.
Yeah, weeks could be 52, could be 1,000 weeks. We can measure anything in weeks.
We can always hope. Any other questions?
Yep.
Well, you have actually a running NX running on GPU Kubernetes containers as opposed to the ones that you probably run away.
Did you hear that?
No, it's really garbled for me.
Do you have Elixir NX running on Kubernetes? Is that
on GPU?
On GPUs.
I don't know, but I see no reason why it wouldn't work.
How are you actually running your amplified GPU loads?
So we're using a combination of AWS and Fly. So Fly now has GPUs. They're really, really convenient, and we use them for a fair amount of stuff. We run a few things still on AWS, particularly like bulk things where we can take advantage of spot pricing. But there are a number of different GPU options on Fly, and it makes life really, really easy. Yeah.
Cool. Yeah, I had noticed that. That's good to hear.
Yeah.
Any other questions? None here. Mike, have we got any online?
Yes, we do. One from Adam regarding Hugging Face support for Bumblebee. I know there is a handful of them already supported. How do we contribute to this as a community?
That is a fantastic question. And I think that that's kind of one of the biggest bottlenecks right now, is just getting in and contributing. One thing to note with that, I mean, basically the way to do that is to go to the Bumblebee library and have a look at some of the existing models. It's not quite as crazy as it seems to be. It's relatively, straightforward. You're basically going in and saying, you look at the implementation in Python, try to understand what's happening mathematically, and try to replicate that in Axon. Again, there are existing things that you can kind of crib off of and understand what's going on there. And as the library expands, there are pieces that are starting to come together that make it easy. So there's like implementations of certain attention mechanisms, for example, that you can just grab piecemeal and construct the support for these libraries. So yeah, absolutely get in and just have a look at the library and try to contribute that way. But I think just one thing to keep in mind is that this is going to start accumulating, and it will make it much easier to implement new models as we start building the building blocks a little bit more.
Yeah, I had a question regarding those publicly available models. Are there any restrictions on the usage, or are you free to use the models for any purpose you like?
They all have licensing information on them. Most of them, there's like, I know, like CC by stuff like that. It depends. It depends on the model, but the Hugging Face model cards all have license information. You can go and have a look there, and you can actually restrict your search on Hugging Face to certain licensing if you've got to comply that way.